Uh, Thank you all for joining us for the Supporting Partnership for Energy Efficiency as a Resource hosted webinar. We're utilizing Slido in this webinar for an interactive aspect. We currently have a poll question that's live. You can take your phone and scan the QR code, or you can go to the website www.slido.com and type in the number 254-7148 and give feedback on what, in one word, what is the biggest challenge for your organization right now. Garrett, Adam, can you see everything good? All right.
Yes.
Yes. Okay. All right. So our presentation today is college campuses energy efficiency success. Over 2/3 of energy we currently consume in the U.S. is wasted. College campuses are no different. In campus buildings consume roughly 80% of all energy universities consume. And improving energy efficiency can cut overall energy use by up to 60%. So in this webinar, we'll discuss the following: operational initiatives for energy efficiency, strategic plans and their outcomes, programs and resources to support energy efficiency implementation. So today we have the University of Texas and Dallas County Community College District, and they'll present methods and their approach to campus energy management. A little bit of housekeeping. You will get the slides via email, as well as receiving the recording within 24 hours. In the follow-up email, you'll receive resources that were discussed and from our conversation at the end of the presentation. And also, if you have any other questions, just feel free to reply to the invitation. I'm happy to answer. And then also, we would love for you to give us feedback on how we did in the survey. And again, please utilize Slido for sending us questions, and it's slido.com. And then you type in the number 254-7148. If the platform is clunky for you, you're welcome to put your questions in the chat. So a little bit about SPEAR. We support energy management efforts across the state. And we do that by facilitating sharing of best practices and energy efficiency while strengthening relationships among local governments. And that's mainly through the City Efficiency Leadership Council. SPEAR is one of 6 regional energy efficiency organizations. One of 6 RIOs. We do work in policy, building codes, high performance buildings, training, and also my program that I manage. Again, my name is Sean Auckland, if I didn't introduce myself, is a local government. Our membership is pretty wide: advocacy organizations, cities, ESCOs, manufacturers, trade associations, and utilities. And a little bit about the City Efficiency Leadership Council. City's in the name, but it supports also school districts, other public entities such as counties, the state agencies, universities, and college districts. We align regional partner initiatives, also provide networking and capacity building opportunities, funding opportunities for projects. I share a lot of information about grants and upcoming funding through the ILA and the BLA and the various grants that are coming through the federal government. We also provide mentorship and then collaborate as a group on regional sustainability projects and initiatives. Again, one last announcement before we get started is that we're offering CEUs today. We need you to fill out the survey. So if you're on a call into this Zoom and I don't see your name on the attendee list, please add your name to this survey and put your phone number there so that we know that you attended. Only you can receive CEUs if you attend the entire hour. It has to be more than 20 minutes. Also, again, if the Slido platform's a little clunky for you, you're welcome to use the chat box Everyone's muted, but you can raise your hand or again, send comments and questions in the chat feature. So without further ado, I'd like to welcome our speakers today. First in the presentation will be Garrett Rosser. He's the energy manager for Dallas College. As an energy manager at Dallas College, Garrett has worked in energy efficiency management since 2011. His current role is budgeting and managing electricity, natural gas, and water. The focus of his role is to reduce usage and costs of the college and taxpayers related to utility resources. In addition to his experience, has focused on saving energy and reducing costs for nonprofit organizations, including churches, other Christian ministries, K-12 school districts, and higher education. He's a certified energy manager, certified energy procurement professional, and through the Association of Energy Engineers. And then following Garrett, we'll have Adam Keeling. He's the Assistant Director for Energy Management at the University of Texas. Adam is currently the assistant. He has been at UT for 6 years, mostly focused on demand-side energy management and recently on generation and distribution. And he's a licensed professional engineer and certified energy manager. Without further ado, I am going to allow for Garrett to share his slides. And so Garrett, you can go ahead and start sharing.
All right, is that coming through all right for you? Great, good morning. My name is Garrett Rosser. I'm glad to be here and join this webinar. And Sean, thank you for giving us the opportunity to talk about what's going on at Dallas College. It's a new day, so to speak. We walk in a lot of the times and we said, well, we used to do it one day and one way, and then but now it's a new day. So I'll talk a little bit about just kind of general changes going on at the college and then how that is impacting and putting us in a better position for energy management initiatives and just things that we want to see moving forward. Let me see here. There we go. A couple of broad topics: organizational initiatives with the college, or operational initiatives and capital initiatives around energy management, energy savings, and generally just utility savings. Water as well has come under me, not energy specific, but we know that there's a strong energy component to water usage. In regard to organizational initiatives, formerly Dallas College was Dallas County and Community College District, which is a mouthful, but really represented the organization and how it was configured. There were 7 separately accredited independent colleges with 7 different campus presidents, college presidents, 7 different business offices, 7 different facilities management groups. And that has all been brought under one organization called Dallas College. And so it's really opened the door for some more universal application of best practices, things that one campus was doing and another might not have been, or even just funding priorities of one business office versus another. We're getting toward a lot more consistent application of those things across all campuses. So if it was good for one campus, it needs to be good for 7 and all of our satellite locations as well. We're about 5 million square feet, just shy of 5 million square feet, and bringing on about another 500,000 here in a current bond, phase 1 of our bond program. So lots of change continuing to happen, lots of change organizationally in terms of people and positions and different things there. The energy manager position, my position, was established in 2020. Previously, there was no centralized management of energy and utilities that was left to the various campuses. We've adopted the state energy management policy, Texas Health and Safety Code 388, and that corresponds to our Dallas College CH legal policy. And then we also have a local energy management policy, which is our CH local designation. And that goes back to 1994. So that's in need of some updates and just some new language to reflect where we are as an organization. So that's one thing that'll be coming here. And then lastly, overall, we want to develop an energy management plan to bring all these things together, whereas they were separate, kind of independent efforts. Again, different campuses had different focus and priorities, so we're trying to just unify all that. Operationally, I think this is where we have so much opportunity, in the near term, and then in terms of a sustainable energy management plan. So one key thing would be the development of an energy management best practices guide, kind of a handbook. And so that's in draft form right now. That will be distributed to all facility staff, especially building operators. And then training will be built around this. So yes, it'll be kind of a handbook reference, but it's really the basis for some one-on-one or small group training that will be delivered. And then some topics below. The big one, utility billing, components and rates, and getting our operators to understand how their daily actions impact the energy bills and different tariff structures that we're on and things like that. And then just some other things that I think are just really core to a foundational energy management operational program. Things related to consistent set points, really good scheduling, opportunities for sequence of operations revisions. We've got a lot of older controls that still work but are in need of some revision. Improved preventative maintenance practices, and then last, building automation system best practices, and just some guidelines about, when is it really appropriate to use overrides and things of that nature. Recently, in the last 12 to 18 months, there's been the establishment of what we're calling the consolidated teams. And these are individuals that hold master level designations in their various trades. Previously, a campus may or may not have had a master electrician or a master plumber on site, but now we've kind of identified and hired in a lot of folks from industry to put them into a position to have a greater impact on as many campuses as they can. So I think that's been really great. And the last bullet point there is probably the greatest value that they bring, being able to go to different campuses and see just generally what looks weird. They bring an outside perspective, whereas campus staff kind of get used to seeing the same thing day in and day out, and they don't necessarily recognize that something might not be either within spec or just generally not operating as it should. It's kind of that repeated seeing thing in the same state, you tend to not recognize it as being a problem. So those folks are making the rounds to all the campuses and really having one-on-one discussions with our campus operations staff, and really using their master level knowledge and training to have a great impact for the college. This is just a quick example of some documentation we're putting together for a set point guide. This would be one part of a handbook that we want to go through different settings within our building automation controls and just make sure everybody is implementing them consistently, and we've got a consistent environment. And then it helps building operators recognize when equipment is not operating correctly, but it also provides for a system that uses energy well and provides a consistent environment for our students and our staff. 4CP for us is a big deal, and I think for many organizations as well. Those 4 coincident peaks in the summertime, and trying to tailor our operations to take advantage of some billing impact if we can reduce our peak demand during those 4CP time periods. This is an example of our Mountain View campus that utilizes chilled water storage, which is a great asset for 4CP demand management. But at every location, when we send out a 4CP alert and get that communication out, every campus is taking action to reduce load during those times, but it's much more pronounced with the use of chilled water storage. And here, the system is not sized to carry the load throughout the full day, but we can use it very effectively during that 4 CP period and through the end of the occupied day. So that just shows, 15-minute interval here of the electricity profile for this meter, and how that chilled water storage is used in the afternoon there. The other thing that was great was an opportunity to have an energy analytics tool, a platform where we can track usage and cost, and just get our head around the 200 plus meters that we have. And I was previously at the North Lake campus only, and I could manage that campus on Excel, but when we started looking at the whole portfolio of meters for every commodity, it became pretty apparent very quickly that we needed some help on managing just the amount of data coming through. So this is a great opportunity for us to have a quick look at energy at a glance, and then we can dig down further into different metrics, different KPIs, by building, by meter, by location. I think benchmarking is something that everybody needs to be doing. And again, with the prior organization, not everyone was doing that at every campus. Some campuses were, others not as much. So if you ask folks, well, how many kWh or BTU per square foot might you be using? They may or may not have an answer. So now we've got that all centralized, and we can communicate it quickly and use that for discussions with our facility managers and operations staff that are really boots on the ground, and making a lot of decisions that influence these numbers. On capital initiatives, again, the different business offices had different priorities, and that became very clear as we start looking at the different campuses and recognize that certain facilities were spending a lot on their facilities to maintain them and to improve energy efficiency, and others not as much. So the business office established the Facility Improvement Plan, FIP, and it really is a funding mechanism to improve infrastructure and real high impact systems. And so that could be roofing, chillers, electrical gear, and that sort of thing, major things that wouldn't happen necessarily with smaller campus budgets, but really need some stronger financial backing. So since 2019, there's been greater than $20 million spent on these FIP projects that also have an impact, a positive impact on energy management, improvements in building systems or equipment to advance our energy management goals. One big thing, 400,000 square feet of high efficiency roofing, and that represents, some multi-floor buildings. So that's about 3 million square feet of our 5 million has new roofs, high reflectivity, high emissivity, EPA Energy Star rated roofs, with increased insulation as well underneath that. We have one site that had, the roof deck, and then some OSB, and then copper cladding right on top. So an R value of about 3. And then that came back with a membrane, single ply membrane roof that's now R30. So those are the kind of opportunities on roofing that we have. And there's some opportunities like that on every campus to improve that. 5 major boiler replacements, 5 major chiller replacements, and on down the line. One thing that's I think really exciting is building automation system improvements. We have 7 different campuses, major campuses, and some of them had more than one front end. So we've got some opportunity to consolidate front ends there and have some more communication, with these web-based options that are the standard now in building automation, where we can have some greater connectivity, not even only within our own portfolio of buildings, but also back to really reliable weather service or to cues from the ERCOT grid and things of that nature. A lot of sequence of operations updates, cooling tower replacements, LEDs are ongoing. And then the last one, power factor correction, not an energy saving measure in and of itself, but a cost saving measure for sure. This is Cedar Valley, and you can see in the top left hand just a standard built up ballasted roof, and then in the bottom left hand going to that white single ply membrane roof, and then the close up shots of that. So that was an entire campus done there. That represents 485,000 square feet of floor space. This is our Eastfield campus out in Mesquite. Some 1969 stamped Cleaver Brooks boilers that fed into a heat exchanger system. They were steam boilers, fed into a heat exchanger as a hot water generator, and then hot water was piped around our campus. So very inefficient, losses at every step of the way there. And the equipment, it was just old and outdated, period. And so you see on the right, just some new condensing boilers, a fraction of the footprint for the equipment, and then equivalent or exceeding the capacity using less energy. That's about across the board has been about a 60% reduction in natural gas on that campus with that change. And then just overall building automation improvements. Yes, we still have pneumatics in some buildings. So that's the case, but we'll look ahead at strategic plan goals here, and getting rid of pneumatics is a big opportunity for us. Brookhaven lighting. This was an opportunity for our on-campus staff to really get involved. So this was an internally executed project. In terms of lighting, LED lighting, we're doing some in-house, we're doing some with partners, and then as turnkey, and then other opportunities where we're buying material, and then we function really as the project manager for some contracted labor. So some combination of all those things are happening on every campus. I mentioned the strategic plan. Again, there was no comprehensive strategic plan. And so as a department, facilities management has rolled out this 5-year outlook of high priority goals. And goal number 3, there are only 3 goals, period. Goal number 3 is all about reducing our environmental impact, not just of purchased energy, but also fuel and waste and water there. But here's some on this first item. So development of an energy management plan and rolling that out with training, with resources for our folks. Retrofitting all of our lighting, make sure we're 100% at least at the Mountain View, Brookhaven, and Ridgeland campuses. Utilizing automated 4CP response. A lot of our response now is manual, so we'd like to take that burden off of our operators. Eliminating pneumatics, again, still present on 3 of our campuses. The other 4 are all DDC. Low efficiency boilers, we still have some standard 80% efficient boilers that need to be moved to condensing boilers. Expanding the use of thermal storage is another big opportunity for us that we're at least going to get going on one other campus, just because it allows us to shift our load, helps us out on the procurement side, and also certainly during that 4CP period. And then just kind of odds and ends, more upcoming controls out at Eastfield. We're digging into individual sites for retro commissioning opportunities, again, done with some of those in-house resources. Automated scheduling is a big deal, trying to get what's in our campus calendar directly into our equipment schedules, and get away from blanket schedules for campuses or for buildings or entire floors. We're really trying to tailor that. I do want to shout out to Encore. They've developed and rolled out this energy concierge program. So if you're in the Encore service area, I would encourage you to pursue that. They've got some folks from Leidos that are administering that, and it's just been really great for the college. And not energy related, but Dallas Water Utility also has a free audit program that I wanted to just say we've been very pleased with the support that we've gotten through that. So trying to take advantage of free resources that are out there, and then leverage and get our skilled in-house folks in the best position to have high impact. And then a couple of other items that we've done related to reporting. and that's all. So there's a lot moving. It's very early on in this process for us with the reorganization and with the move to one college, but it represents some great opportunity for us to really unify our operations and get everybody consistently doing the same right things related to energy management. Thank you.
Thank you so much, Garrett. That's a lot to kind of go through, and we have several questions to follow up on that. Adam, if you want to go ahead and share your screen. I guess while we're waiting for him to share his, oh, there we go. We'll go ahead and hold the questions for the end.
Okay.
All yours.
Whoops, hold on, it switched on me. Let's try it this way. There we go.
All right.
You seeing the right screen now?
Yes, we do.
All right. So thanks for having me. My name is Adam Keeling. I'm the Assistant Director of Energy Management at UT Austin. So I'm gonna just kind of like Garrett, just go over our campus, our history, our energy management practices, and some project examples, and then we'll take a look at our dashboard that we built. So our main campus is about 19 million square feet of conditioned space. We also have a Pickle Research Campus in North Austin that we haven't put too much focus on. So I'm mostly going to be talking about main campus. There's about approximately 160 buildings, very old to brand new, as typical for a college campus. As you can see, there's about 25 buildings being built every year, every decade. We have a combined heat and power plant serving main campus and chilling stations. So we distribute electricity, our own generated electricity, steam, chilled water, and a few buildings are getting heat and hot water. And to manage all that, we have thousands of meters, both on the plant, chilling stations, as well as in the buildings. Quick map of our district energy system. So we have 2 gas turbines. So overall, big picture is our plant consumes natural gas, and that's it, in order to make those distributed resources. So we have 2 turbines that are consuming natural gas, as well as 4 boilers. There's some heat recovery steam comes off of the turbines that go to, there's some heat recovery steam generators. Some of the steam from the boilers, as well as the steam generators, goes to steam turbines that also contributes to electric power. We do have a connection to Austin Energy for backup, but we rarely ever use it. Some of that power goes to our chilling stations. We have 5 chilling stations of 60,000 tons, and the rest of the electricity goes to campus buildings. So obviously our chilling stations are making chilled water. Some of that goes to thermal energy storage tanks. And then we also have a new hot water plant, or a few years old, that's distributing some heating hot water to buildings. So why energy management? Pretty common question for anywhere. Campus is constantly growing. We're trying to avoid expanding our utility plant generation because it's expensive and we only have a certain amount of space to expand. Where we 70 megawatts is kind of like our cap that we want to stay under. We have the capacity for a lot more than that, but if you get more than that, you start to use older, less efficient equipment, which means things are more expensive and less reliable. So we had a lot of plant side efficiency efforts for the past, I'd say 15, 20 years. But just since 2012, the demand side energy management group started. That's what I'm going to focus on. That's where my experience has been. So on the right is just overall results of EUI. Main campus EUI is the line, and the bars are gross square footage. So our square footage has grown from about 16 million to about almost 20, and our EUI has decreased over that time. We use source EUI for everywhere. So kind of our overall approach is, if you think about the life cycle of a building. So there's some period before the building is just being thought about, the design phase. Then there's building construction, which is actually a very small sliver in the life of a building, and then operation, which lasts for very long, especially for a college campus, because we're owning those buildings forever. So the opportunity to make changes looks something like this, and the cost to make those changes looks something like that. So it's clear that it's the ideal time to influence a building's energy use is from the very beginning. So that's what we try to do for capital project support. We try to get involved very early. This blue line is kind of representing what's going to happen without energy management being involved, and then the orange line is with energy management being involved. So as through the design process, we try to find ways to reduce consumption. Then once it's built, you would think that energy use stays flat in buildings, but as things degrade, as things fail, as humans are involved in disabling points on the BAS and things like that, the energy use creeps up. So we have an ongoing monitoring commissioning process to prevent that drift. Then we also do projects to bring that energy down. And then again, continue with our ongoing commissioning. So there's basically three approaches to the design. So capital project support, ongoing commissioning, and then projects. So the capital project support, we have a lot of design and construction standards. There's a link here that goes to UT's. It's a public website, has all of our design and construction standards. But as far as energy goes, the stuff that we have mostly participated in is we have a energy and water performance requirements, some energy model requirements, EUI and WUI targets by building type. Oh, it's really by space type. So if a building is 50% classroom and 50% lab, we would average that, or we would take half of each of those. So you can have any mix of any type of building on campus and kind of create its own. Every building on campus has its unique EUI, basically, target. We have a sequence of operation guideline. It's based on ASHRAE guideline 36, but a bit simplified from that. If anyone's familiar with guideline 36, it's pretty complex. We have a sustainable design criteria coming, as well as new construction commissioning, lab ventilation management. These are just some of the big ones that we've gotten involved in. And then we participate in project design reviews to basically verify that our projects are meeting those standards that we've written. So that was kind of our one of the three. The second of the three is the idea of ongoing monitoring. Pretty straightforward. You basically, rather than just letting the building go, you are very diligent and closely monitoring meters, the consumption, closely monitoring the BAS, staying in touch with staff, occupants in the building, students, the building managers. And then if you have fault detection, also you can use fault detection. So just closely monitoring for issues and analyzing those and then getting them fixed, sending them to the right place to get fixed. This is a very high level, but pretty simple idea, but can get very complex and complicated. So we're actively involved in this. We have a couple buildings on fault detection right now. We're using the continuous commissioning from Energy Systems Lab. And the way that we're doing it is we put it on a building as part of an existing building commissioning project or retro commissioning. And we use that as we're doing the retro commissioning, as we're updating sequences of operation as part of the project, and then it stays on afterwards. Versus the alternative would be just throwing it on 10 buildings and just starting to use it. We figured the best way to do it is kind of one at a time, putting it on buildings as we do the retro commissioning projects. In order to use fault detection, you have to have DDC. So like at Dallas College, we have a lot of pneumatics still, not a ton, it's slowly changing. This is our current situation. We only have about 27% of our buildings with full DDC. And then we have a lot of, you can see, you add up those three big chunks of pie. We're at 3/4 of campus that have air handlers on DDC. So that's been the main focus the last 10 years or so, is at least getting air handlers. Getting zones on DDC is more difficult because you're having to invade the occupant space in order to change out the terminal units. But and then we have 4 different BAS platforms at the moment. So that was 2. This is number 3, energy projects. We gotta have four different types of four main types. We have, like what I was talking about, retro commissioning HVAC controls. Just kind of think about like your Nest thermostat in your home. It's like a smart control of your HVAC at your house. In a commercial building, if you're not familiar, it's way more complicated. So we're basically coming in like a Nest thermostat and enhancing, making those controls smart of the HVAC. There's scheduling of the HVAC, big thing. I mean, before this group started in 2012, none of the air handlers were on schedules. So easy win. Exhaust fan improvements on our lab buildings. I'll get into that a little more later, and as well as a handful of lighting projects here and there. As far as scheduling goes, daily, what I mean by daily is just getting them the daily schedule in. Turn off at 10, turn on at 6 a.m. or whatever it is for each building. Like I said, these were not in place before 2012. Doing this was easy, low-hanging fruit in our first few years. Averaging 18% savings, it cost us nothing, just a little bit of time. We also do scheduling over holiday breaks. We save about 16% in each building that we do that in. We have some COVID scheduling that we worked around with COVID, again, saving about 18%. And then we're trying to get, like Gary mentioned, at Dallas, we're also looking into linking our Outlook scheduling calendar to the BAS. I said Outlook, but the reality is there's a bunch of different systems that are used, and that's what's one of the main challenges, is a lot of different people use different systems for scheduling their classrooms. So here's a lighting retrofit in this library. If you look at the ceiling of that library, it is insane. It's just covered in light fixtures. So and it's 24/7 because it's a library. So We this is a TLED relamping project. So fixture stayed in place. We retrofitted the ballast and the T8 lamps into TLEDs. So if you're not familiar, it's basically a fluorescent lamp, tube lamp replacement versus changing the whole fixture. Save 12% in electricity, 3-year payback. Performing Arts Center, if anyone's been to the Bass Concert Hall, this was from a few years ago. This is a kind of a typical retro commissioning project that we would do. So it involved adding a schedule to the HVAC, optimizing the controls, the BAS sequence of operations. This was kind of unique in that we have both a normal and an event mode. When there's thousands of people in there, it goes into event mode. It has different set points and whatnot. We did a little small lighting retrofit, a few other things. Here's some M&V results. The purple is the baseline. The red is actual. Saved 32%. So pretty darn good. Here's another project example. The NOC is a data center area in a building. Somehow, for some reason, 3-way valves got installed in the AC units, meaning rather than the valve stopping the chilled water from going through the unit, it just diverts it around the unit. And so it doesn't control any flow at all. So we were only getting 1 to 2 delta T with chilled water at this data center, which is kind of nuts because data centers are big users, just because the flow is out of control. So got some control valves. And the problem with low delta T is it makes your chillers run very inefficiently. So we installed some control valves, got it down to 130 and 8 to 10 delta T. Just 3% electricity in the building, but didn't cost very much either, only $12,000. Exhaust fans are huge. If anyone is managing labs, you should look at your exhaust fan systems. If you quick down, look at the middle of the page here, our first project, which is the biggest one, is saving 3 million kWh per year. Putting VFDs on 450 horsepower exhaust fans. So basically that picture on the right is a wind tunnel model. And what that is there's a few companies that create a model of the area around your lab building, and they basically look at stack velocities for safe dispersion of your exhaust from your lab. So you've got a bunch of stuff going on in labs, a lot of bad stuff being created and being exhausted. And so it models different wind speeds in different directions to make sure that bad stuff isn't affecting other buildings or is basically getting safely away from everybody. And so the idea is you could just turn your fans up to 1,000,000% and easily get it out, but obviously that's wasting energy. So you're trying to find that balance of what's the least amount of energy we can use and be safe at the same time. So that's what wind tunnel modeling is. Another example is vacuum pumps. This is more of a water project. So if you have vacuum pumps, also used a lot in labs. This is one specific project, but it's actually been done 3 different times, where there's what's called water ring pumps. And they're basically just have once through water going through the pump constantly. It's being run 24/7. The water is used to cool the pump. And once through water being dumped to the drain. So they have these different types that are oil, have some recirculating oil rather than the once through water. So again, easy, low-hanging fruit. saving $8,000 in water every year. So here's just a quick summary of some of the projects that we've done over the years. So we're averaging about $9,000 in cost. Does not include staff labor. We've reduced hot cold calls for maintenance by 18%, about 20% energy reduction per project, 30% peak chilled water reduction, and saving about $23,000 a year per project. So 0.4-year simple payback. So now moving on, so that was a lot of demand side stuff. I'll touch a little bit on supply side. This is, we use a company called Optimum Energy. So to help optimize our chilling stations. So this is the dashboard that we have through them. We have the chilling stations, and we have 2 thermal energy storage tanks. Here's a history of the supply side. I went into way more detail on demand, like I said, because I know more about that. But if anyone's interested, here's a quick list of supply side optimization. Mostly chilling stations. Not much to do in the electrical / steam generation. Or at least we haven't focused on that, because the low-hanging fruit was on the chilling stations. Quick graph on some results from the TES, thermal energy storage. So those were built in 2017, 2018. This is a daily profile from kind of peak season, early August to mid-September. And this is watts per square foot for main campus. So you can see it's as expected. It's without thermal energy storage is the orange. It's, it dips down in the middle of the night and peaks in the afternoon. And with the thermal energy storage tanks, we've been able to pretty much completely flatten that load through the day. And a lot of that has shifted to night, but just because things have also gotten more efficient, the night hasn't really gone anywhere. We do have some solar panels on campus. There's 2 on main campus and 2 at Pickle. And we just recently completed an assessment and to look for issues. And we're currently working to repair those issues. And then we're going to create we assume that there's going to be some more solar coming in the future. So we're making sure we have some design and construction standards created for that. And it's saving us about $46,000 a year. And this is our energy hub, our dashboard that we have online. It will be public soon. And if I'm not sure, I'll check how much. We're at 10:48. I can show it real quick, or do we want to go to questions?
No, go ahead and show the dashboard.
Okay, I'll show it real quick. Okay, here's a map of campus. So it's color coded by building type, and you can, by the size of the bubble, is depending on whatever you selected here. So you can select by total energy or by a single commodity. You can look at total consumption, greenhouse gas emissions, or use intensity, so normalized by square foot. So it's kind of a nice visual way to see things. You can also look at it. You can also look at the same data in bar graph form. So let's simplify this by, let's just take labs. You could look at just labs, and it will put in order total building consumption. So you have all your labs here from biggest user to lowest user. And then use intensity versus the target. So like I said, every building has this unique target. And so you can see which buildings are how buildings are performing versus their target, and compared to each other. You could look at individual buildings. So this is a dormitory. We have the building space use type breakdown. Like I said, this is a dorm, 89%, some public assembly, some office. As a target EUI, actual EUI, target water use, actual water use. So this building is doing pretty good. And you can see over time, this is my favorite to use, is our use intensity versus target. So this is each one of these lines is a different commodity. So you can see chilled water, domestic water, electricity, steam, and total energy. And this dashed line at 1 is the normalized use intensity target. So you can see this we started a project back in 2017 that reduced this consumption. Then project was over, kind of flattened out. COVID hit March 2020, dropped off a bit, and things started picking back up. So it's a cool way to see how it has performed over time. This is showing a whole decade here. Our district energy, we have a lot of metrics here. Greenhouse gas emissions over time, total plant, the district energy system efficiency over time versus baseline, heat rates, electrical efficiency, kW per ton. And then we have, I'll jump to our projects. So we have all of our demand side projects here in a energy savings stacked bar chart. So you have different energy results over time from our different projects. And that'll do. That's the highlights.
Thanks so much, Adam. I really like that dashboard. I have a few questions about it. Well, we've gotten a few questions in that I'm actually going to record, and after, if you have further questions, feel free to put them in the chat, or you can go to slido.com and type in the code 2547148. So one of the questions is for the ongoing monitoring slide, how is analysis done? Is it human manual analysis or automated with technology, AI, ML? I
guess either of us, we kind of both touched on that a little bit. I can start. So it is, it's a little bit of a mix of both human and automated, manual and automated. We do have, like I mentioned, fault detection on 2 buildings. So that's somewhat automated. It essentially looks for faults on the BAS and sends reports out to people that would then have to go and review the fault detection dashboard and then create work orders to send to maintenance to go out and further investigate and fix things. We also are monitoring our meters, looking for anomalies in meters, and that is also semi-automated. We have predictive models, regression models built for each commodity at each building that are looking for when it goes as an outlier. Basically, we have a kind of a threshold, plus or minus threshold to the model. If it exceeds that model, then that also creates a flag for someone to look at. But then again, it takes a lot more investigation. There's a lot of manual process, and then going and looking at the BAS, talking to the building managers, talking to the zone staff, trying to find something that has happened.
So when you were explaining that to me, what's your staffing like, Adam, to implement that type of examination? How many data analysis building operators do you have?
So we're on the utilities team, actually. And the facilities team is separate. So we're utilities and energy management. And we have, our team is kind of in flux. We're going through a lot of changes. We basically have like 4 people that are doing some sort of monitoring as far as energy management, looking at watching the meters, looking at the fault detection. There's also a separate team in the facilities group of BAS analysts that are BAS operators that are also looking at the BAS. So they're looking at it more from an operational standpoint, less focused on energy management.
Okay. What about for you, Garrett? How would you approach that question?
In terms of dashboard or staffing or both?
Dashboard, then staffing.
Yeah, in terms of identifying any type of commissioning opportunities, that really is at this point a campus by campus kind of manual check of, like Adam had mentioned, what is the meter data telling us to guide some opportunities on which buildings to look at, and then digging in building automation systems and trying to figure out where the opportunities are there. So, and then again, the dashboard has some alarming set in, but it's not as sophisticated as what Adam is able to have there, where we're just looking at month to month variation or year over year variation. And then there's some alarming alerts that go out from that, not related to weather normalization or a baseline target, but just raw usage, and then that plus or minus variance, similar to what Adam had mentioned. And then staffing, we've got me as the energy manager, and then we have 3 building automation technicians and their manager, and they're really going out to, they're the consolidated team. And then there are several building operators. So again, it kind of goes down the line. I'll see something either with the meter data, or just kind of glance at a system and see something that's off. I like to do overnight checks because a lot of our campuses are shut down overnight. So that gives me an opportunity to see what's running and then kind of check that against trends, and then generate work orders from there and say, ask folks and working through the campus teams, can you check on this, or have you noticed this, and just kind of do things that way. And then myself making on-site visits, on-site visits to dig in deeper on other items.
Well, thank you for answering that. You both have immense jobs, and I hope that you all get recognized in all the great work that you're doing. This is pretty amazing. We only have a few minutes left, and I wanted to also ask one more question on when there was the response with the word cloud that staffing was the biggest challenge. Do you find staffing being a large challenge for you all in your space?
I would say for us, for sure, there's a lot I feel that I can do. And there's a lot of work that gets done through others, but it would be great to have an energy analyst, that really was dedicated to just looking at meter data day in and day out, and doing some analysis and looking at the interval data and trying to look for anomalies in that, and tie that to operations, having the skill set to tie that to building operations and equipment operations. I think that would be huge for us, but there's a lot of work that's getting done with the folks that we have. So I'm happy to have strong working relationships, but a lot of our folks are more maintenance oriented, building operations oriented, not necessarily energy minded. So not first. I think Adam and I probably lead with energy use or energy efficiency first, and then also frame that with how our building system's working, whereas a lot of folks that are end users from our side, operators, they're really focused on comfort and kind of some more fundamental operations and things like that. And that's really the focus of their job. So there's got to be more opportunity for us to have some training and just kind of, and I think it is working energy efficiency, working its way into the fabric of what we do and working commissioning activities into the fabric of our preventative maintenance schedule, rather than them just being these one-off things we try or initiatives. It's just going to be the way that we do business from here on out.
So like I mentioned, my team is just energy management, and we haven't had too difficult of a time with staffing. There's a lot of young people these days are really focused on energy. There's a lot of people that are excited about it and have a passion for it. So my team in particular hasn't had too much trouble filling positions and finding qualified people. I think facilities, on the other hand, is a different story, especially the BAS. People with BAS skills and experience. I know that they've struggled. Also, finding people, because we have so much pneumatics, finding maintenance people who have still know pneumatics, I think has been difficult. Everyone's moving to DDC, and so finding people who know how to do pneumatics is I think has been a challenge from what I hear.
Well, I want to thank both of you who are at the hour. Thank you so much for taking time to present. I've definitely learned a few things, and there's a few questions that we didn't get a chance to answer. So I'll send them over to you if you could take a moment, and we'll send out the slides and the link to the YouTube video, as well as the answers to those questions. You'll be receiving them by Monday. So thanks again. We appreciate your time.
Thank you, John.
Thanks so much.
And those of you who are still on the webinar, here's some ways to connect with SPEAR through eepartnership.org. We have a Facebook, Twitter site, then also a YouTube video site with over 100 educational resources. And thank you for attending.